Welcome viewers. In this lesson, we will going to discuss about the pin configurations of 8051 microcontroller. So before moving to the lessons, this is our lesson outcomes. By the end of these lessons, student will able to identify and describe the function of each pin of 8051 microcontroller. That means in these sessions, we are going to discuss the functions of each and every pin of the 8051 microcontroller. And also, after the end of these lessons, the student will able to explain the significance of IO ports, power supply, power on reset, oscillation connections, and the reset pins. Okay, so let's start about the today's lessons. So this is the pin configurations of the 8051 microcontroller. So you can see this 8051 microcontroller has a 40 pin DIP, a dual inline package. And within this 40 pin DIP, it have a various input output connections for the communications with the external devices and also to perform the various operations inside that microcontroller. Here I must say one thing that in these lessons we are going to discuss about this 40 pin 8051 microcontroller. But in market, also there are a 20 pin 8051 microcontroller is also there. Okay. So in that microcontroller actually, some of the input output function is missing. We cannot have four ports, 32 numbers of the input output line. So actually we have to compromise in the input output line sections. But in market, for 20 pin 8051 DIP is also available. But this 40 pin 8051 IC is the most prominent one, and we can also discuss various operations in the last lecture in the architectural block diagram sections. Whatever the functions, whatever the features we will discuss that 8051 microcontroller have. Actually, all those things we can observe in this 40 pin IC. So that's why I consider this 40 pin IC for the discussion purpose. So first thing is the VCC and the VSS, and this is the supply line and the ground line. This 8051 microcontroller runs with a plus 5 volt, and the ground is definitely connected to the ground. And the 40 pin number is the VCC, and the 20 is the ground. Okay. Apart from this VCC and the ground, it have two pins for the oscillator circuit, crystal oscillator circuit. And those two pins are 18 and 19 number of pins, and they are designated as external 2, external 1 respectively. In the last sessions, we will discuss that it have a on-chip oscillator circuit. But I also said that although it have that, we require some external clock to run this 8051 microcontroller. So how that connection is looks like, you can see in these connections, it will have an external 1 pin, external 2 pins, and these 2 pins is connected through a crystal oscillator via a capacitor. Okay, and more specifically, the value of this capacitor is the 30 picofarad capacitor, and they are also connected to the ground. So this is the typical structure to connect the crystal oscillator to the 8051 microcontroller. Now, here we must know that one thing, that the value of this crystal oscillator is a typical value is there, actually a peculiar value is there, and that value is 11.0592 megahertz. Okay, and in market also you can have this value of crystal oscillator is available, right? So why this peculiar value is there? Because during the serial communication sections we will discuss that this value will going to match the baud rate. The baud rate is very essential whenever we are trying to communicate with the other external devices via serial communications. So what are the popular baud rates are there? 9600, 4800, and all those baud rates are matched with this external frequency, the crystal frequency. So that's why we must say that whenever our microcontroller or the 5.1 microcontroller is are going to use for the serial communication purpose, we need to connect this crystal oscillator. Okay, otherwise we cannot match the popular baud rate that is commonly available, commonly used, right, in the serial communication. But if you use for the other applications, we can choose the any other oscillator values. Now, in the last session, we will discuss that it have a on-chip oscillator circuit and that will actually divide the crystal frequency by 12. Okay. And the on-chip oscillator circuit will specify one thing that in this 8051 microcontroller, one machine cycle is equals to 12 state. And we know that one state is nothing but 1 by crystal oscillator, crystal frequency. Whatever the crystal frequency we are going to connect, one state is nothing but 1 by that. And so one machine cycle is what? Is 12 T state. So one T state is 1 by crystal oscillator. So one machine cycle is equals to 12 by that crystal oscillator, oscillation frequency. So if I connect the crystal oscillator having a value of 11.0592 megahertz, so in that case, the machine cycle, one machine cycle value is 12 by that value, that is 11.0592, and that exactly equals to 1.085 microsecond. So if you connect this crystal oscillator, one machine cycle stands for 1.085 microsecond. If we connect 12 megahertz, then 12 by 12. So in that case, the one machine cycle equals to 1 microsecond. So definitely, if you increase the crystal oscillator value, your machine cycle will be going to be decreasing in nature because it is inversely proportional, right? Apart from this crystal oscillator, we can also connect some clock sources to give the optimum frequency of the clock. So clock frequency to that 8051 microcontroller. In that case, if we have a TTL clock source, then that TTL clock source should be connected to the external 2 pin, whereas this external 1 pin should be grounded. Okay. Similarly, if we have the CMOS clock source, then that CMOS clock source should be connected to the external 1 pins, whereas the external 2 pin should be no connected. There should be the no connections with an external 2 pin. So the 8051 microcontroller can have two options, that we can connect the external clock crystal oscillator, or we can also connect the clock source that is made up by the TTL clock source or the CMOS clock source. So these are the connections for this microcontroller. Next pin is that pin number 31, that is the EA bar or the VVP. The full form of this EA bar pin is the external access. This external access pin is the input pin to that microcontroller, and we must connect. Definitely, we must connect. We cannot let blank, or we cannot make it a NC connections. So we must connect this pin either to the VCC and to the ground. So what is the function of this external access pin? We know that in the last configurations, in the last architectural block diagram, we have discussed that the 8051 microcontroller have some amount of the internal ROM, that is a 4 kilobyte of ROM. 8052 have 8 kilobyte of ROM. So and the 8031 have 0 kilobyte of ROM. So it might happen that 4 kilobyte of ROM that the 8051 microcontroller have internally, but we require more than of that memory to store a particular program. Then what should we do? Then we need to interface the external memory with that IC. Now, how the 8051 microcontroller will identify that they should or the microcontroller should fetch the program memory from the internal or the external one. For that case, this EA bar pin is very, very important. What this EA bar pin is says that if this EA bar pin is connected to the ground, the 8051 will not read the program from the on-chip ROM. Whole program it will read from the off-chip ROM. Off-chip ROM is it's the externally interface ROM. That means you can see in this diagram, if the EA bar pin is connected to the ground, hold the 64 kilobyte of the ROM space. Why it is 64 kilobyte? Because it have the 16-bit address bus. We will discuss in the previous lessons. And so this is 0000 to FFFF. So 64 kilobyte of the ROM space is there. So hold the 64 kilobyte of this ROM space. It will actually fetch from externally. So this is very, very important for the 8031 microcontroller because 8031 microcontroller is ROM-less microcontroller. So we need to store the program in the external memory. So in case of the 8031 microcontroller, the EA bar pin should be connected to the ground. What happens if the EA bar pin is connected to VCC? Whenever the EA bar pin is connected to the VCC, first that microcontroller will fetch the internal ROM. After that, it will fetch the external ROM or external memory. So in case of the 8051 microcontroller, we know, we also discussed in the last lesson that in this 8051 microcontroller, it have 4 kilobyte of the on-chip ROM. So in this case, this EA bar pin is connected to VCC means the 8051 microcontroller first fetch this internal 4 kilobyte of the ROM. After that, it will fetch the external remaining memory. That means the 60 kilobyte of the ROM. Right? So this is the function of the EA bar pin. If it is 8052 and EA bar pin is connected to VCC means, first it will fetch the internal 8 kilobyte of ROM, then the remaining 56 kilobyte of ROM externally. Okay, so that's why I said this EA bar pin is should be connected either VCC or to ground, such that the 51 microcontroller or the microcontroller will know that where from the program should be fetched. Next, most important pin is that the reset pin, and the pin number 9 is there for the reset pin. Now, a high pulse in the reset pin must be high for minimum 2 machine cycle before it allows to low. This is very, very important statement is there. Whenever we are give the power to the 8051 microcontroller, that is also known as the power on reset. Why it is power on reset? Power on reset means whenever we will give the power to the 51 microcontroller, it will be resetted. That is known as the power on reset. Also, if I give a manual reset also, okay, so whenever we want to reset that microcontroller, the essential statement or essential criteria is that we need to give a high pulse for at least minimum 2 machine cycle before it goes low. Now we know what is the time period for the one machine cycle. We will discuss just before that if the crystal frequency is 11.0592 megahertz, then one machine cycle is equals to 1.085 microsecond. So that means to make the proper reset, at least 1.085 microsecond multiplied by 2, that time period, for that time period, that reset pin should be high. After that, it goes to low. Now the question is why this time period is required? What the microcontroller will do during this time period? Because in this time period, it will actually stabilize the power as well as the clock frequency. Whatever the power source is connected to the clock frequency is connected to the internal blocks, they will stabilize, and all the peripheral register interrupt, whatever the things are there, all those peripherals must have to be set at a safe value. That means they will be reset at an initial value. We said now the reset value. What is the reset value of the program counter? It should be reset to 0000 hex. So all those registered peripherals and interrupt are set to a safe value, or we can say it will be set to the resetted value of the initial values. Okay. So to do these two initial conditions, the 2 machine cycle is required by this 51 microcontroller. So to do so, the power on reset circuit is looks like this. So you can see this power on reset circuit, this VCC is not directly connected to the reset pin, but there is a RC circuit out there. So typically it is a 10 microfarad capacitor and 8.2 kilo ohm of resistance is used. And through these RC circuits, the VCC is connected to the reset pin. So we can change the value of this 10 microfarad or 8.2 kilo ohm of resistance. But one thing we should keep in our mind that the time period should be 2 machine cycle. If that will satisfy, then definitely I can change the value of this 10 microfarad or the 8.2 kilo ohm of the values, right? Now, what will happen whenever we'll give the VCC or the power? So initially, this capacitor will fully discharge. So whenever we'll give the power supply, this capacitor will going to charge. And during that time, in that this point, okay, just a minute. Yeah. So during this time, this point, we will get just the value of VCC over here. Okay, just get the value of VCC over here. And whenever this capacitor will get fully charged, we will just get the zero voltage over this point. So what will happen? During this charging period of the capacitor, this reset pin will be high. Once the capacitor will be fully charged, it will go slow. Okay, we know the RC circuits. What is the charging time? So that charging time, that means the switching from the high pulse to the low pulse, that should be minimum 2 machine cycles. So this circuit is known as the power on reset circuit. Why it is power on reset? Because whenever we'll give the power, initially the microcontroller will be resetted. And initially the 2 machine cycle time should be given to that 8051 microcontroller to do those essential conditions, right? That means for these 2 machine cycle, this 9 number of pin or the reset pin should be high. After that, it will go slow. So this is the power on reset circuit. Apart from that, if I want to give the manual reset, then what we will do? We will connect here a manual switch. Okay, it is a push button switch is there. So whenever we'll connect this switch, we'll press this push button. What will happen? This VCC is directly connected to reset pin, right? The voltage will follow the voltage will follow this line, right? So VCC will be directly connected to the pin number 9 of the reset pin. So that means the reset pin having the high pulse. Whenever we release the switch, again the reset pin will be goes low, right? So in the manual reset point, we must press the switch for minimum 2 machine cycle, right? And 1 machine cycle is 1.085 microseconds. So 2 machine cycle is around slightly higher than the 2 microsecond. So it is very, very less time. So whenever we'll press a switch, that will be definitely more than of that time period, right? So that's why a debug switch or the push button switch is given. So whenever we'll press that switch, VCC will connect it to the reset pin. Whenever we release that switch, it will again goes low. So that will the manual reset we will give to the 8051 microcontroller. Next, the pin number 30 and the pin number 29, and the pins are ALE and the PCN bar. In the last lecture, in the bus control sections, we have discussed that whenever the microcontroller is going to interface with the external memory, basically that bus control section will going to be control the bus, right? External bus. And two signals are there in that bus control section. One is the ALE and one is the PCN bar. What are those things? The first thing is the PCN bar, the pin number 9. PCN bar means it's the active low signal. And the PCN bar is the output pin. Okay. So output pin means the signal should be coming out from the 8051 microcontroller that should be connected to the external any of the external devices. So where that should be connected? So that PCN bar pin should be connected to the enable pin of that external ROM. OE pin. OE pin means enable pin of the external ROM. So through that PCN bar line, program store enable. So we are going to enable the program memory. So through this PCN bar line, we are going to enable the externally interface ROM memory. Okay, so this PCN bar line will be connected to the enable pin of the external ROM. And we know that in most of the ROM memory, the enable pin is also active low. So that's why the PCN pin is also active low. Okay, so that will be connected to the enable pin. Another pin is that the ALE. I think this pin is familiar to all of you. That is known as the address latch enable because in the microprocessor sections, we will understood the function of this ALE pin. So actually, in the port sections, whenever we'll discuss about the port structure, we'll see that each number of data bus line or data lines are actually multiplexed with the address line, and they are known as the AD0 to AD7. So this ALE pin is also an output pin that will actually demultiplex the multiplex address or data lines. Just for a recapitulations, I will say that what is this multiplex address and data lines? That means a single line can act address bus as well as can act the data bus. So how we will define or the microcontroller will define that when that particular line will connected at the address bus and when it will be connected at the data bus, that will be going to be defined by this ALE pin. Okay, so it will actually demultiplex the multiplex address and data bus. Okay, so that's why these two pin, PCN bar and the ALE pin, is basically used whenever we are going to interface the external memory. So that's why these two pin is there in the bus control sections. Now we already know in the last lessons that it have 4 ports and 32 numbers of the IO lines. So we will not going into detailing of this port structure because in the next lessons there's a separate lessons I will conduct in the port structure, how the internal connections are there in the individual ports. So I will not discuss more in these lessons. So just we will discuss that what are the ports are there and what are the dual function of all those ports are there. So it's a port 0. So port 0 can be used as a simple input output port. Apart from that, it have a dual role of the port 0 is that it is also connected as or it is also used at the AD0 to AD7. That means the multiplex address bus as well as the data bus. What is AD0 and AD7? D0 to D7 means 8-bit data bus. 8051 have a 8-bit data bus. A0 to A7 means lower order address bus because we know that 8051 microcontroller have 16-bit address bus. So 16-bit means A0 to A15, right? So A0 to A7 means lower order address bus as well as multiplex with the 8-bit data bus. So port 0 have a dual functions. It can be used simple input output or it can be used as a AD0 to AD7. One of the interesting thing is that the port 0 is having a special structure. Whenever we will discuss in the next sessions, we will see that why it is a special structure. And for that case, the port 0, whenever the port 0 is used as an input output mode, okay, whenever it is used as an input output mode, not as a use as a for the AD0 to AD7, we need to connect a pull up register, okay, externally. Why we will definitely discuss in the next lesson. This is the port 1 and port 2. Port 2 is pin number 28 to 21. Port 2 have also a dual role. It can be used as simple input output as well as this port 2 can be used for the higher order address bus. You can see the A8 to A15s are there. Okay, so lower order address bus is port 0, that is pin number 39 to pin number 31, right? And port 2 is the higher order address bus. If you remember in the last lessons, I have give you the hint, then during the IO port structure, I said that port 0, port 2 is written simultaneously. After that, port 1, port 3 is written. Why? Because here the port 0 is there. Here it is the port 0, right? Here it is the port 2. That's why port 0 and port 2 are in the same side. Port 1 and port 3, here the port 3 is there, are also in the same side. Why this is like so? Why not port 0 and port 1 in the same side? Because this port 0 is known having a dual function of AD0 to AD7, right? So whenever, and this pin number 30 is the PSEN pin, and this is the ALE pin, right? So whenever we are going to interface the external memory, what are the connections we have required? EA bar pin, PSEN bar pin, ALE pin, address and data bus pin, right? So all those connections are in the same side. The port 0, port 2, and PCN bar ALE, all those pins are in the same side. So that will require less wire to connect the external memory. So that's why they have designed such a way. In the port one is just it's a such kind of port in the 8051 microcontroller have that doesn't have any dual role, that doesn't have any dual functions. Only the port 1 can be used as a simple input output port. Okay, so that's why my suggestion is whenever you are going to use this 8051 microcontroller for any kind of project work, if we require to use a input output port, always the preference should be given to the port 1 because that doesn't have any dual role. And the last port is the port 3, the pin number 10 to pin number 17. The port 3s are there, port 3.0 to port 3.7. Definitely the port 3 have some dual roles. And what are those? The first two pin is RxD and TXD. So port 3 pin number 0 and pin number 1 is used for the serial communication. Pin number 2, pin number 3 is used for INT0 and INT1, that is external interrupts. We'll discuss in the last lessons that it have only two external interrupts, that is external interrupt 0, external interrupt 1, and they are connected via port 3 pin number 2, pin number 3. Pin number 4, pin number 5 is for the timer 0 and timer 1. Pin number 6 and pin number 7 is for the read write pin. Okay, so port 3 having a dual function and through this port 3 we can connect the serial communication, timers, external interrupts, so on and so forth. Okay, so my suggestions whenever in the project work, don't use the port 3 for the simple input output port initially, because we don't know whenever we record the serial communication of the external interrupt pins. Okay, so we should leave the port 3 for that. So this is all about the 40 pin IC and their individual functions of this 8051 microcontroller. So that's all for this today's lessons. In the next lesson, we will discuss about the port structure. We'll see internally that how the port 0, port 1, port 2, and port 3 are connected. Okay, so that's all for the today's sessions. Thank you very much.